Good morning, good afternoon, good evening, wherever you're hailing from. Welcome to another StackRox community office hours. This is episode 2. We're going to be talking about eBPF 101 today, and I'm joined by the one and only Robbie Cochran. How are you, Robbie?
I'm great. Glad to be here.
You want to introduce yourself to the audience just to let them know who you are, what you do around these parts?
Yeah, absolutely. I am an engineer at Red Hat. Formerly was an engineer at StackRox, and have been working in Kubernetes security for a few years now. And in particular, I've taken a focus and interest in Kubernetes security and eBPF together.
Nice.
And yeah.
Cool. So we have a doc with some questions in it that I'm trying to pull up. First question. What are the use cases for eBPF?
So eBPF, you can think about eBPF as a better way to extend the kernel. And the use cases are pretty wide open.
Yeah.
Observability, security, networking features. Ultimately, you can think about, I like to use the analogy, and I know this has been used before, from the perspective of a web browser without JavaScript is kind of like a Linux kernel without eBPF. And if you think about all the things you can build with JavaScript in a web browser, and the way that Linux kernel development used to go is that you would have to, if you wanted some new feature in the Linux kernel, you'd have to go talk to kernel maintainers or write your own kernel module. And what eBPF provides is a way to get data from the kernel, the Linux kernel, as well as take actions on events. And that may seem like kind of a not that big of a deal, but it allows for a whole nother layer of tools and techniques and things to be built on top of the kernel. And another way to think about the use cases of eBPF are, I don't know, your persona, or, what is your role, and, what problem you're trying to solve. The first way, and I'm going to give a demo in a few minutes, that I think about it is in terms of just debugging. So I want to know, is this, think about a breakpoint in your code. I want to know what's happening when this function within the kernel is being called, or how many times it's being called, that sort of thing. So performance counters, things like that. There have been subsystems built into the Linux kernel, but ultimately you run into, this feature isn't available in the subsystem, like the perf subsystem, the audit subsystem. These things are not extensible. And what eBPF allows you to do is attach small programs on these events and then report data back into user space. So you can have a user space program that understands what's going on. In addition, you can actually write new networking stacks within the kernel in the eBPF. And then if you need to update them or change them or configure them, you're able to do that.
Nice. So, if I were a new person using eBPF inside my cluster, like, what would that look like from a pod perspective?
Yeah, so there's several ways. So let's say we have a K8s cluster up and running, an OpenShift cluster, and we want to understand what's going on within the cluster. So we have a performance issue, for example, and maybe it's related to disk activity. You could use eBPF scripts and tools and piece together kind of an idea of what's going on by just extracting the data and getting performance metrics. So this is, observability from the observability standpoint. Another use case is if you want to actually use eBPF to help with security. So visibility, less about getting sampling and aggregate information from the kernel, but more, I want to see an audit of all of these events and have it correlated with additional pieces of data, like the container ID or the network connection that a process made or something like that. And so that's one way to get use eBPF in your cluster. I think from the individual perspective, the debugging is kind of the debugging and performance analysis is the first entry point. It actually requires, just like building a large web application on JavaScript, a lot of effort. Building a platform that's built on eBPF is, a significant effort. And so there's a lot of existing platforms and tools and things that are available. So for example, the StackRox product now, ACS, uses eBPF to extract process executions as well as network connections from the kernel. And what's great about eBPF is it allows us to operate on any kernel version, kind of going back to that challenge of any recent kernel version. That challenge of, we're not able to add StackRox specific features into the Linux kernel. We don't want the customer to have a special kernel. We can just insert an eBPF program within the kernel and then get this data out.
That sounds way easier than running custom kernels everywhere.
Yeah, totally. Yeah.
Cool. So I think of eBPF and I think of tracing in kind of the same vein, right? You said debugging, right? There's nothing better than running an strace on a process, right? Really seeing where it's breaking.
Right.
Does eBPF give us more insight, less insight? I mean, what does that look like on Kubernetes?
Yeah, so strace, if for folks aren't familiar, strace is kind of an old school system call tracing approach. And it uses, it kind of ping pongs back in between user space and kernel space. So you can print every system call that an application is running. And that's super useful for determining, what actually is happening when I'm reading a file or, so the problem is that strace has a huge performance overhead. Because it's essentially adding an extra round trip between user space and kernel space. The cool thing about eBPF is that you can, of course, eBPF can introduce overhead because you're doing work, some sort of additional compute within the kernel, but you can be selective about it. You can say, I want to record all the system calls and then report them out, that sort of thing. Right. Yeah, you could easily build an strace on top of eBPF.
Right. And getting those system calls, very telling, very helpful. How would you install it, right? How would you get eBPF in your cluster?
So why don't we do a demo?
Yeah.
Let me show you guys some, let's see. Share my screen. And before I do that, I'm going to go through just a little intro on some slides here. Is that visible, Chris?
Yes.
Cool. So kind of as I was saying, we have the Linux kernel, which is hard to update. And then we have our application stack on the right. That's just a set of processes. And, these could be running within containers in our cluster, but ultimately the processes are sending information on the network, reading and writing files, or launching other processes. And since the Unix API, the POSIX APIs were created, it's been a stable place to run programs on Linux. So you can run exec, you can run open. It doesn't matter which version of Linux you're on or which flavor. However, within the Linux kernel, there's all these different subsystems: the memory manager, process scheduler, disk, network. If you want to get data about those internal components, it's difficult. So you can either write a kernel module or actually submit a patch to the kernel maintainers, and that takes a lot of effort. So we have this stable API for our user space programs, but we don't necessarily have a good way to extend the kernel without a lot of effort. So what eBPF lets us do is add hooks within the Linux kernel, and whatever we can add the hooks at the syscall level. So that's thinking about strace, where we want to see all the interactions between a given process and the kernel via syscalls, or we can attach eBPF programs to any function really within the Linux kernel. Of course, the syscall layer is going to be more stable. So I think the easiest way to get up and running if you have a Kubernetes cluster and run some eBPF programs is to use a really nice tool called kubectl trace. That's what I was going to give you the demo of here. So cool. This is available here at this GitHub URL, and the prerequisites are really just you need a Kubernetes cluster up and running. So let's see, I'm going to share my terminal. So I have a cluster, a K8s cluster running, and I'll show the nodes. So let's see, we've got, make sure we can connect to the cluster. There we go. Nice. So we got 3 nodes in this cluster. In fact, let's look at what the host OS is. So these are running Ubuntu 20.4, Linux kernel 5.4. So that's, you're normally when you have a K8s cluster, you're not really thinking about the node level. Nodes are cattle, they come and go. And what eBPF allows us to do is kind of get into the Linux kernel on the host. So we're kind of getting underneath our containers and seeing what's happening. Right now, this is a completely empty cluster. So there's no pods. Of course, if I check the kube system namespace, oops, we'll see that there are there we go. So we've got the base containers that are actually running in Kubernetes. So even though there's no applications running in this cluster, there's still stuff going on. Yeah. So what we can do is use kubectl trace, and kubectl trace is a kubectl plugin. There is essentially it allows us to still use the kubectl command, but then it calls out to another process. And so we can run kubectl. We can install kubectl trace using crew, which is a kubectl plugin manager, or just downloading the binaries directly. And kubectl trace allows us to run BPF programs, and particularly a particular type of BPF program called a BPF trace program, which is a higher level scripting language that's built on top of BPF. And as I said, this is, I think, the easiest way to get started with running eBPF in your K8s clusters. So what we can do is let's see what processes are running on a particular node. So of course I could exec into the node and look at, there's a lot of different ways to get that information, but let's see how we would do that with eBPF. So I'm going to get nodes again, and then I'm going to run a BPF trace program. Let's start with exec. So what this is going to do is it's going to run a K8s pod on this node. G4X2 is the particular node, and it's going to run this exec snoop program. So we start that, it creates a pod, and this pod has to be configured a certain way. So we can actually look at it. And let's describe this pod. Actually, I'm going to edit it so we can see all the different configurations. So what's key about this is it's running a container that is actually just kubectl trace BPF trace. And the other kind of key thing here is that it's running with admin privileges. So the security context here is privileged. And if we're going to execute BPF programs within a container, we need to be privileged because the BPF system call, which is, we're monitoring system calls or observing system calls. We also use a system call to insert the program. It requires admin privileges. So I've run this trace program. Now I want to see what's actually running. So we can tail the pod itself, which is actually going to be just printing the data it's getting from the BPF program. And so this is just tracking it's adding a BPF program to the exec system call. looking at the arguments and sending them back to user space. And so from a single container, we can see all of the process executions that are happening within on the host system, within each container, and on the host system itself. And so this is actually kind of a cool way to see what's going on, what kind of activity is happening on a K8s cluster. There's a lot of just version checks and sanity checks, some health checks, that sort of thing.
That's cool though.
Yeah, so we ran this program called exec snoop. So let's look at that program. And this is kind of when I was saying earlier about how, one of the first places I think people end up using eBPF is to diagnose performance or other kind of issues in their cluster. So, you might want to see what's running in a pod or that sort of thing. Mm-hmm. And this BPF program is very simple. I mean, here's the code right here. It attaches the hook that we're attaching to is the syscall for exec VE. And we are just combining the arguments and then printing them out. So an exec system call has a path associated with it. And we're also printing the process ID.
Okay.
These programs can be run using on any Linux system. I think all distributions have these tools available in their package repositories. I'm talking like if you're not on a Kubernetes cluster, you're just on a Linux box. Yum install BCC tools or yum apt-get BCC tools. You'll actually be provided with a lot of these programs. Okay. So there are. This is just exec. We could also look at networking. Let me delete this trace and
look at you with your clean hygiene, your wonderful pristine cluster.
I know, right? This cluster has never seen any high CPU. All the CPUs are just ready to go. Mm-hmm. So what I'm going to do here is, let's see, what do we want to do? I'm actually sure. What do you want to see, Chris?
Well, what do you got? I mean,
well,
there's a directory of BPF trace programs. I'm curious what's in there.
Yeah. So this is the kind of default programs, and of course, all of these are, I would say it's not too difficult, not too much effort to extend them for what you need. And the Snoop programs are particularly interesting. And you can imagine there's a couple different models of getting data out of the kernel. You can just stream all the events, or you can also aggregate within the kernel. And then, so let's do connections. So TCP connections.
What's something that's actually going to give us a bunch of results?
Yeah. Mm-hmm. So we'll see. Let's get the logs for that. Now this is probably going to be really active. There's going to be a lot of connections, and this will show us the. Just stream this into a.
Cool.
Okay, so this is just a snapshot of connections that were being streamed via this eBPF program. And we're getting the PID, the command of the program. So this is the command is going to be stored in the kernel, and it's just reading that data. I'm going to get the source address, the destination address. And so we can see all of the connections that are being made and which program is making those connections. Like say there's a curl that's probably a health check, just checking for readiness.
Yeah.
We've got kubelets talking to the API server most likely, and so on.
Very handy.
So yeah,
you talk about performance metrics, right?
Mm-hmm.
Like, and can you show us anything around that?
Sure. Yeah. Let's take a look.
Show us the performance of a trace. That'd be super meta.
Yeah. And I think that's worth mentioning. If what's the overhead of running eBPF, anything based on eBPF within your infrastructure? And I think strace is a nice example because we were describing strace. For every system call, you're adding an additional round trip because it has to go in and out of the kernel. So you want to make sure that whatever events you're attaching to aren't too frequent, and that the data you're extracting is reasonable. Of course, you could attach to every function in the kernel and just completely, DOS your system, or you can have, kind of targeted events that you want to get information about. And there are a lot of ways to aggregate data. So eBPF provides different techniques for getting data out of the kernel. One approach is histograms and maps and so on. I don't know if there's a good way to do that with these programs. Oftentimes you kind of want to build a flame graph or some kind of more visual view of this data. This is kind of the raw data coming out, but let's say, just for example, you might want to see, I think what's really nice is looking at TCP issues like drops or TCP lifecycle. That can be very helpful for networking, debugging,
and everything.
Yep.
So, question came up in chat: where did these programs come from?
Yeah, that's a great question. So these are BCC programs. Okay. So let me go back to my slides, and I'll kind of give you a better idea of the ecosystem of eBPF.
Okay, cool.
So let me actually go to switch down a few slides. Okay, so this is from the eBPF.io website. This is an excellent resource for eBPF, and it's recently forming, kind of an open source consortium of developers and companies and everyone that's interested in eBPF. And these, what I just showed you with kubectl trace is a BCC program. Those are BCC programs. So this is the logo for BCC. And these are available on, GitHub. So you can download these. And of course, there's a lot of, oops. Sorry about that.
No worries.
So yeah, I was going to try to show you the website, but I'll just tell you what to search for. So yeah, BCC tools are what those scripts were in BPF trace programs. And then we were running those using the kubectl trace. It's a lot of BPF and trace and tools and that sort of thing. Yeah. I think that it can be overwhelming when you're looking at all the different ways that BPF can interact with all these different kind of subsystems. Mm-hmm. The key thing is that, the use cases of networking security and observability and tracing are kind of where you want to start with. I would say BCC tools are ideal for observability and tracing. And these are historically based on the dtrace approach in Solaris. Yeah.
So is IOVisor BCC the right repo to get these from?
Yeah.
Okay, cool. I'll drop that in chat, folks.
The BCC compiler collection or BPF compiler collection is what these are, toolkits and wrappers for writing eBPF scripts. You still need to write in kind of a pseudo C, and then the BPF trace programs, which I showed you guys, are built on top of that.
Cool. Kubectl trace was from chat. Kubectl trace makes things easier. How do we use it to generate flame graphs?
So
that earlier.
Yeah, I think that the best way, probably one of the most full-featured toolkits for generating data like that is the vector subsystem or vector system from a performance monitoring system that's Netflix has open sourced. And also, you can generate flame graphs in different ways. You can just have, text histograms, but I think the vector performance management system is ideal for flame graphs.
Okay, cool. I'll find that for folks. Drop them a link. Sorry, I'm in a sea of web pages right now. So what has been done to harden the eBPF subsystem, right? Like, how do I know this isn't a backdoor?
Right.
Like, is this something I need to watch, right? Like, are people making eBPF things out of my
yeah.
cluster,
So
right?
the kind of going back to the, what are the alternatives to running, this container that is inserting these BPF programs is running is privileged. So of course you want to make sure that your user space code that's managing and running your eBPF programs is secure and managed properly. The verifier, there's kind of two angles to that question. So one is, what's this, is this going to crash my kernel? Is this going to crash my host? And then the other angle is, is this secure? And I would say that, there have been there hasn't been an eBPF attack, but there has been some data leaks and things that enabled with eBPF. But really, any user of eBPF has super user privileges, and so that's something to watch out for. Now, of course, the verifier essentially that your program must pass is built into the Linux kernel, and it will the verifier will ensure that the code terminates and isn't going to get into any infinite loops. In fact, unbounded loops aren't allowed in BPF programs. The BPF instruction set is actually quite constrained in what you can do, and that helps a lot with security. Null dereferences, a lot of the kind of caveats that come with writing in C that you would have if you're writing a kernel module are not there with BPF, because it's got more safety features and it's a more constrained language.
Okay, so very tightly scoped. That's good. Very, sanitized, for lack of a better term.
Yeah, and I would say that if you're using eBPF, it's essentially a sandbox within the kernel. And so that you get the security guarantees of that.
Nice. Awesome. So what about, are there any downsides to eBPF, right? Like we talked about overhead a little bit. What other downsides are there potentially?
I think there really are no downsides, because of course that's a very blanket statement, but maybe what are the issues that it can bring, I guess, is maybe a different way to think about it. And so I think one challenge is making sure that you're running on a kernel that has, you really need to be on a more recent kernel. There's been a lot of effort and changes that have been added to the Linux kernel recently. And so if you're running in the cloud, you're going to be using a more recent kernel. But if you're in an air-gapped environment or running older distribution, you're not going to have all the most recent eBPF features. Red Hat has backported a lot of eBPF to older versions of RHEL. And so usually, I think if you're on RHEL, you're going to have all the features you need. But making sure that your host can support eBPF is key. The other challenge is, so I mentioned that we're essentially extending the Linux kernel. And in order to do that, you need to know what is the layout of a particular struct that I want to get data from. And across Linux kernel versions, those struct layouts will change. And so in the kubectl example demo I just showed, what actually is happening is we need the Linux kernel headers in order to run the BPF program. So when we compiled that script into BPF bytecode before it's inserted into the kernel, the headers are needed. And that can be very challenging because, especially if you're trying to support, you're developing software that you want to run on a variety of different Linux kernels. and coming from someone who's worked on a security product that you want to run on a lot of Linux kernels, that's a challenge. And that's something that the BPF community is very well aware of, and they've been adding features to export the struct formats and the data types within the kernel so that you can just subscribe to that. It's called BTF or BPF typed format. And there's another initiative that uses BTF called core, or compile once, run everywhere. And that's kind of the ideal end state for these tools, is that you're able to write a BPF program and run it anywhere. But right now, that can be challenging because only the most recent kernels support that. Depending on if you're on a cloud, if you're in the cloud, it's going to be supported, but otherwise maybe not. That's just something you'll have to look into. Yeah. The other challenge I would say with BPF is it's still relatively new, and you're running code in the kernel. And even though this is a great tool to get information out of the kernel, and you said something earlier about profiling the meta of BPF,
right?
That can be difficult. Anytime you're adding overhead within the kernel, if your application's slowing down, maybe that can be difficult to diagnose. There are tools and techniques being kind of developed for performance counters and measuring. Okay, I want to see how much time is being taken every time. For that example, I was only attaching to the exec system call or the TCP connect system call. But if you've got a lot of places that you're attaching, you're going to want to profile these and make sure that, especially in production, if you're running eBPF in production.
Nice, good call. Is there anything else you want to just show off with the eBPF? Is there anything you think people's minds would just be blown by it?
Yeah, let me go back to this this slide here. And I think that so we have this bottom layer, the Linux kernel, and this is I would consider this slide from the kind of the roadmap of eBPF. There's eBPF is being added to the Linux kernel. Microsoft has been adding an eBPF layer to Windows.
Yep.
There are several SDKs for writing eBPF, because not only do you have to write eBPF code, you also need the framework to help you inject the program and kind of manage it and get the data out of the kernel. And so there's Python and Go and C++ and Rust libraries for doing so. And then on top of those are these tools and platforms that are being built. And I think that's probably the most interesting thing going on with eBPF is, it's good, just like it's good to know about assembly code, but no one's actually going to be writing assembly code usually.
Yeah.
And so it's really cool to see what people are building on top of eBPF. From the perspective of security, the coolest thing is to be able to have a way to not only get data from the kernel, but actually take action within eBPF. And so that's where I think when people start writing, and this has already begun, writing eBPF programs that actually can take action within the kernel, then there's a lot of really interesting tools and platforms that can be built. So from the perspective of security, there is a new Linux security module based on eBPF called, I'm not sure if I get this right, but Kernel Security, it's KSRI.
Okay.
Kernel, or maybe I got the SNR swapped. Kernel Runtime Security Instrumentation.
There you go. Okay.
And what that allows you to do is actually have checks. So, is this process authorized to take this action? Mm-hmm. And you can just deny it. And so those types of rules can be updated and tied into the higher application or authorization frameworks. And what's great about that is it's, anytime you're taking action within the kernel, it's performant because it's not requiring you to go back and forth between user space and kernel space. The other place that's really interesting is just observability. So there's a lot of observability frameworks. Pixie is one observability framework. And I think in general, if you're doing any kind of application tracing or monitoring, it's going to ultimately be based on eBPF. And I haven't really specified this or kind of gone into detail about it, but not only are you able to trace events in kernel space, you can also do that in user space. So you can you essentially use eBPF to check breakpoints in user space or to look at events in user space. And basically you can imagine that just opens up a whole world of observability, and, just flame graphs are kind of like the beginning of all the different ways you can dive down into what's happening. So security and actually doing enforcement, that's one area that's, I think, super cool. The observability frameworks that are being built on top of eBPF, and then finally service meshes and networking. So Cilium is a K8s CNI plugin. So it's an eBPF based networking plugin for Kubernetes. And I'm not an expert on Cilium, but my understanding of what the benefits it provides is, again, you're able to not have to use IP tables to manage the connections between deployments or even between clusters. This can all be configured within eBPF. And, there's a component of the Linux kernel called XDP, the Express Data Path. And that is used often by hardware manufacturers to tie, as a way to integrate their NICs with the Linux kernel. But then also you can have essentially a software layer built in there. And so that's what Cilium is, a kind of software eBPF based networking plugin. Katran or Katran is a load balancer based on eBPF. And even Calico has added eBPF features. So I think, moving forward, if you're running a service mesh, it's also going to kind of probably be built on eBPF.
Yeah, it'll have some BPF components to it, it sounds like, for sure. So quasi question / you might not know the answer to, but wouldn't eBPF effectively introduce a stable kernel interface and permit proprietary programs for the kernel?
Yes. So
yeah, I'm sure that's a contentious thing. So
So I'm actually not sure I completely understand what the questioner is asking in terms of where they're going with that. Of course, if you are writing a BPF program and it's inserted into the kernel, there actually is a GPL license check in the verifier. And so as I'm not a lawyer, but you still have to, if you're going to be interacting with a GPL API within the kernel, then your BPF code needs to be open source as well. So, I think that's an interesting idea. I'm thinking from the perspective of hardware, like a device driver or something like that. I would say that, this is already feasible with kernel modules and other things. The kernel is already extensible. This is just an easier and safer way to do it.
I think safer is kind of the easiness aside, this is just safer to do than like building kernel modules left and right.
That's right. Yeah.
Yeah. And to be honest with you, I don't know where 8th Doctor was going with the question, but if that didn't answer your question, 8th Doctor, please let us know. Khaled Raid says, the most interesting thing to me is how you can control network traffic on layer 7 with eBPF. And that is super awesome. The fact there's a load balancer that uses eBPF behind the scenes. I don't know how you could extract any more performance out of the kernel than that. I've never used Katran before, but it's got to be fast and performant in all kinds of different ways.
Yeah, absolutely. I mean, that is, essentially you're giving these kind of core data paths context, and user space can provide the context through eBPF, and then you're able to build these performant networking tools. Whether you're doing packet inspection or taking action on things. I haven't seen anyone do like an IDS and eBPF, but those types of things
that would be cool.
Yeah. Yeah. I think, and maybe going back to the challenges,
yeah,
you are limited to how complex these programs can be.
right.
I'm not sure off the top of my head how many, there's an instruction limit on how many instructions can be in the program. And so, I think when you're thinking eBPF, you're thinking of small snippets and like, you're building together, for Cilium, Falco, these projects have large eBPF programs, but they're really pushing the limits of the size of what you can do. So you can't build you can't have a machine learning engine running in your kernel in using BPF.
Right.
So you are limited to also the limitations of the eBPF verifier, as I was saying earlier about bounded loops and what memory you can access and that sort of thing.
Yeah.
And,
so
yeah.
Detective Conan Kudo, he basically, the issue here is that proprietary programs for the kernel that are tied to specific kernel versions bring us back to the problem that prevent people from upgrading kernels in the first place. I don't think eBPF does that here. You have that instruction set limit. It doesn't live in the kernel. It calls the kernel, right? Like, so it's one of those things where it's like if people are concerned about this causing you to like stick to a certain kernel version, I don't think that's the case. This is going to be persistent in kernels going forward. You're able to run the same, traces as before.
Right. Yeah. I mean, it's important
right?
to
like, yeah,
we're not hot patching the kernel.
No.
We're kind of it's event driven hooks that we're taking action when that event happens, and so that does have certain kind of limitations. You can't necessarily like change code paths or that sort of thing. You're adding on additional you're extracting data or now, for example, if you do the thing. So I described from the perspective of attaching to system calls, but Cilium, which is attaching to the XDP subsystem, you're extending that. So rather than going back and forth between user space, you're going between your eBPF program and that subsystem within the kernel, if that makes sense. And the same with Linux security modules. You're not necessarily, you need to have some code within the kernel that allows you to then do those actions. And so I think it does from the perspective of Linux kernel features being added, knowing that you can build a subsystem with the idea of users using eBPF to then make it what they need to be, it's like to extend it the way they would like. The Linux kernel, if you're previously without eBPF, you had to be very opinionated on how things were going to operate. But now you can have the framework, and then users can write their security rules or audit rules, for example, for the kernel security instrumentation, runtime instrumentation, and use them as they see fit. Yeah.
Cool. So we got about 15 minutes left. Is there anything that we haven't touched on that you want to? We talked about the cons. We talked about what has been done to harden the eBPF subsystem. We touched on that a little bit.
So
limits and stuff like that.
Instruction call limits. I think from the beginning, eBPF is one of those acronyms that doesn't really have any meaning anymore, because it kind of we're talking about the whole eBPF subsystem and all these platforms and things when we say eBPF, but ultimately it's extended Berkeley packet filters.
Yeah.
And so Berkeley packet filters and IP tables have been around for a while, and so I think it is secure through the simplicity in that you need to have a constrained programming language or instruction sets. And once you have that, then it allows for the verifier and static analysis to be much more effective, because we're not exploring, a million different paths. All the different paths in your eBPF program are essentially walked to look for nullity references, to make sure that there's no way that you're going to dereference a null pointer. And also the kernel provides a lot of eBPF helper functions, and that's usually what's used to get data. So you're using the helper functions to then interact with the rest of the kernel within eBPF.
That's cool. Okay.
Yeah.
Awesome. Folks have already asked about Cilium. I've dropped the link to the Cilium page for that. Let me
so I would definitely want to mention that the eBPF .io organization I think it just finished like an hour ago, had a summit yesterday, and today is the second summit. They had it last year for the first time. And for people that want to know more, particularly about the lower level details of eBPF, but also just different use cases, definitely check out the eBPF summit. It's free; all the videos are online, that sort of thing. There's a lot more information there, and it's
find a link. Go ahead.
It's and there's an active community, and kind of like I said before, depending on what persona or what role you have in your organization, your interaction with eBPF may be either debugging, or you're just using a platform that happens to be built on eBPF.
Right. Yeah, that's a good point. I'm looking at this schedule. It's intense. But typical suspects: Liz Rice, Yana Dugan, all the fun people, Tabitha Sable. All the low-level folks I know that know everything about syscalls are speaking at eBPF Summit, so that's cool. We also have we're a Diamond sponsor for the Cloud Native Security Conference coming up at KubeCon. Are you part of that, or?
I'm not planning
in any way.
I'm not planning on presenting, but okay. I will. I'm sure I will be involved one way or another.
There's just to read a little bit. There's a hosted capture the flag learning experience that will run in parallel to the event for attendees to learn firsthand practical attack defenses and techniques.
I think those capture the flags and those hands-on labs and demos are such awesome ways to learn.
The capture flag demo that was done during KubeCon EU was just fascinating to me. And like the second we found the problem, because we were running out of time, and I say we because it felt like we were all working on it together in the live stream. It was just like, oh, there's the problem. That's the naughty bits right there. Let's get rid of those, and off we went. But it was a nice little.
You have a lot of those aha moments where
you can really get an eye-opening, kind of mind-blowing experience from some of those sometimes. Because you can easily stick something on a Linux box and make it do bad things.
Yeah, and I think there's something really exciting and cool to be able to get information from the Linux kernel and get into these low-level details. You really kind of opens up your eyes into like what's going on. Those are great learning tools.
Absolutely. Anything else for the audience you think they should know?
So I can share some resources.
That'd be great.
I've kind
slides are up, folks. I'll get you the link.
No need to get your pen and paper out for this one. I kind of broke down some of these resources based on, if you're going to want to do eBPF development. I think eBPF development is going to be, most likely associated with some sort of platform, right? You're using eBPF within Cilium or that sort of thing. But for scripting and debugging and that sort of thing, the kubectl trace is a great place to start. And then there are books. Brendan Gregg is the resident expert at Netflix on eBPF. He's got a great book on performance and observability with eBPF. And there's a lot of platforms. Red Hat Advanced Cluster Security for Kubernetes, we use eBPF. Falco, Aqua has some eBPF tools, Cilium, and so on.
Yeah, no, this is a great.
So there's a wealth of information available online, and like I said before, I think it can be really overwhelming when you're getting started, like looking at these things, and just start with something simple like BPF trace, and I think that's a good starting point.
Yeah. I'm looking at questions here. Are there any chances Red Hat will become a member of the eBPF Foundation? I do not know. I have no idea. Have you seen any discussion on additional stack unwind support for eBPF?
No, I haven't. But that is always a pain point when looking at, performance counters and things like that, where you want to be able to, diagnose issues. I know that Pixie has done some work on performance, kind of continual performance monitoring with eBPF. And I believe they've opened, I don't think they've yet open sourced they have a community edition, but they have some interesting blogs about performance or profiling with eBPF.
Okay.
I can share that after the talk. Yeah.
Yeah, that'd be great. Yeah. And that's so, Conan Kudo says, I hope they don't do too much more for eBPF. If the goal is to not be Turing complete, then it needs to be fairly restrictive. I mean, do you know of anything on the horizon for eBPF that would give folks reason for concern?
So no, I think the language is going to stay relatively stable. The instruction set, I think there's been recent work to add atomics, and also additional like Linux features to get data out of the kernel. And so there's several different ways to you can insert a BPF program just using the BPF system call, but then to get data out, the program can write to a perf buffer, or also there's BPF ring buffers, which have more performant characteristics. And so I think really the language, the instruction set will stay relatively stable, but then it's all of these kind of tools and other ways to interact with it that are going to change.
That makes sense.
Yeah, and grow.
Awesome. Well, cool. I don't have anything else for us unless you do, or the audience might toss in something here at the last second. Who knows? But this has been awesome. This has been very insightful. I'm glad you came on today. Thank you so much. Thank you to the audience for your questions and participation. This was awesome. What's next? Yeah. I mean, where do we go from here? And,
I think you're just going to see more products and tools powered by eBPF.
I dropped the projects link, and I noticed that like some of those are newer projects that have come along in the past few months. So I expect to see a lot going on in this space as more people become aware of it, right? Like having the second BPF summit.
Yeah.
That's a big deal.
It just really fits well within like, the microservices architecture, and like where we have all these ephemeral containers and clusters in our environments. And you need a kind of a way to slice through, not horizontally, but vertically. What's the user space program doing? What's the kernel doing? And eBPF is kind of like the best way to do that right now. And so I think, like I said, there's going to be more and more things built on BPF.
Awesome. Well, Robbie, it was great having you on. Thank you.
Thanks for having me, Chris.
Hey, no problem. And we do these, I forget how often we do these. Hang on a second. Let me double check. Please, obviously, please come back for the next one, but the next one is, I forget. I believe these are monthly. So confirm. None. That is incorrect. But so here's a better idea. Subscribe to our calendar, and you will get all the fun links to all the programs that are coming up on the show or the channel. And highly encourage you to do that so you can keep up to date with all the latest and greatest cloud native fun things we're doing here at Red Hat. So Robbie, without further ado, thank you very much, and y'all stay safe out there. See you soon.